All right, let's look at the homework 10.5, problem number 7. All right, so let's go through this process. Step 1, so we want to find, I guess we just have to find the derivative and plug in 4, right? So I'm going to actually use GeoGebra to do this. All right, so first thing is I'm going to define f of x. Right, f of x colon equaled, and then in this case function is square root of x. That hit enter. Right, now function is defined. Right, so I'm gonna find the f prime of 4. So we can just do f prime of 4. Right, hit enter. So it's 1/4. So we can just do 1/4. Right, and then let's do the third derivative. So we can actually go back, and then third derivative would be, I'm going to just put the 2 more primes, right? Then hit enter, right? So we get the 3 over 256, right? 3 over 256, right? Then the last one is the sixth derivative. So I'm going to go up here, right? And I need the 3 more prime. So 1, 2, 3. Then hit enter. Alright, so we got that. I'm going to actually copy this and let's see if we can get it to over here. Okay, so here it's a little, I have to, a little bit of editing here. So it's a negative 945 over 131,072. Right? So let's check the answer. Alright, I came back and looks like we got these ones correctly. Alright, let's do part 2. Alright, so we want to find the Taylor polynomial of degree 6. Alright, so we're going to do that using GeoGebra here. Alright, so we want to find S sub 6 of x, and we're going to define it as, right, Taylor polynomial. We can just spell Taylor, and there's a suggestion here. All right, so function is f in this case, and the value is, let's see, center is at 4, so the x value is 4, right, and the order is 6, right, and if you hit enter, right, so we'll see the, this is actually, you might not be able to see the whole thing here. This is the Taylor polynomial. So what I'm going to do is I'm going to let's say I'm going to copy this, right, and then put it in here. So it doesn't copy very well, but we can work with that. So I'm going to say, right, copy that. Alright, so I just have to change a little bit here. Alright, so you don't need to find the name here. So it's a negative 21 over that, and then maybe I'm gonna just say this. Alright, over. Alright, then I'm gonna just copy this. Alright, Control C, and then just to delete that. Right, delete, and then put that, copy that down, so paste here. Right, and that's going to be the x to the 6th power. It doesn't look like it right now, so x to the 6th power. I just have to clean that up a little bit here. All right, I'm going to go up, yep. All right, so next term is 77 over, right, then I copy this part. Right, yeah, Control C, and then get rid of that, and then paste it here, Control V. All right, so get rid of that, so you have 5 there, and get rid of those. All right, so it's going to be negative 495 over, all right, so I'm going to just copy that, get rid of that, and put it in here. And I'm going to just get rid of that multiplication sign, and I have a 4 right there. All right, so we have that over, right, so it's 8192. So this is easier to just type it in. Then I'm going to just cancel, get rid of that. And so that's the x cubed term. Right, so this divide by, right, 8192 again. And then we get rid of that. Right, 2, and get rid of that. Right, so it's going to be 1024, and get rid of that, and we get x. Right, get rid of that, and it's almost there, so it's going to be 512. Right, get rid of that. Alright, so let's check the answer here. Alright, it came back and looks like we got the step 2 correctly. Alright, so we want to find s of 6, so Taylor polynomial degree 6 evaluated at the x equals 5. So here, we already defined it as s of 6. So what I'm going to do is I'm going to, let's see, I have some extra stuff there. Alright, so I'm going to write s of 6 and then plug in 5 and hit enter. Alright, so we get this value around to 4 decimal places. So I'm gonna say numeric, and let's see how, I don't know how many points, so I'm gonna put 3. That's not enough, so I have to put 5 there. Alright, so 5. Alright, so it's 4 decimal places, so 2.236. So I'm going to just copy this and then Control V to paste it. Alright, so let's check the answer. Alright, I came back and looks like we got this one correctly. Right, then we want to determine the maximum error of this approximation. So R sub 6 is, this is the remainder. So let's work with that. Alright, so we have this Taylor's theorem with remainder. So remainder can be written in this form, right? Let's see, we know something already, right? So we know that n is 6 in this problem, so n equals 6, right? And x is given, c is given to be 4, right? And x is equal to 5 because we're plugging in x equals 5. All right, so we're looking at a remainder with n equals 6, right? This is going to be less than or equal to maximum possible value of the absolute value of, let's see, it's going to be 7th derivative because 6 plus 1 evaluated at z, we don't know z yet, right, over 7 factorial, and x equal to 5, and c is equal to 4, and raise it to the n plus 1 is 7. Alright, so let's find this. This is going to be the upper bound. Alright, so 5 minus 4 is 1. 1 to the 7 is 1. So this part is just 1. Right? So we can actually just scratch that out because multiply by 1 doesn't really change anything. Right? So, and remember, 7th derivative of f at z, and at z is, it says somewhere, z is between c and x. So this is, let's see, where z is between c, which is 4, and x is 5, right? So let's look at the 7th derivative and see what we get, right? So that was the 6th derivative, and here's the 7th derivative. Actually, why don't I just do it down here, right? So I'm going to take f 7th derivative, right? So 1, 2, 3, 4, 5, 6, 7th derivative of x. Right, so I'm gonna just say hit enter. All right, so it looks a little bit weird because it doesn't cancel x's here. All right, but I'm going to go ahead and cancel x's, and you notice that x is going to be sitting on the bottom. All right, so we're looking for the largest possible value we can get out of this expression. All right, so z is between 4 and 5. So what we want to do is, since the x is on the bottom, we want to make the x the smallest possible. Right, z is the smallest possible. So 4 at 4, z equals 4, this is going to be the largest possible. Right, so what we can do is we can just plug in. Right, we take the seventh derivative, and z is going to be 4. Right, or actually z is not equal to 4, but it's going to be bounded by seventh derivative at 4 over 7 factorial. Alright, so let's compute that quantity. Oh, let's see. That's not what I want. Let's compute that quantity here. Alright, so this is a seventh derivative, and what we want to do is we want to plug in 4 in there and divide it by 7 factorial. Right, 7 factorial. Right, then we're going to get a numerical value, so I'm going to say numeric. And then we can do, I don't know how many, I'll just put 2 for now. Alright, so you can see that this is going to be the value 0.000002. Alright, so let's type it in. So we got 0.000002. Alright, so let's check the answer. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.